Now we're going to be taking logarithms and we're going to be writing them as a single log, or in other words, condensing. So the reason why we can write these as a single log is because they have the same base of b. So you have to kind of go backwards in what you just did in the properties. Since you have log base b of x plus log base b of y, this is written as a single logarithm, log base b of x times y. Okay, so take a second and try number 2, except now you have numbers that you're working with, not just variables. So since it's log base 2 of 9 plus log base 2 of 3, this is going to stay log base 2, but it's going to be 9 times 3, which then we can simplify and say log base 2 of 27. This next example is the quotient property. Because it says minus right here, that tells us that we're going to have log base 4 of 2 divided by 6. So if you remember before, the log that has the minus in front is the number that goes in the denominator. Now we can simplify this, and we're going to say log base 4 of 1 over 3. Now in number 4, I'm going to add a little addition to a problem like number 3. Okay, so this is number 4. Now there's a lot of 3's going on, but I want you to just use the properties and then we're going to simplify. Because the directions say write as a single logarithm, I do not want you to simplify and then work with the logs. I want you to write it as a single log and then at the end you simplify. So the first thing I notice is this 3 in front here. This is going to fly up top to be log base 3 of 3 to the 3rd power. So with that being said then, this is still the quotient property, so we're going to have log base 3 of 3 to the 3rd on the numerator, and then because that negative sign is in front of just the log base 3 of 3, we're going to divide by 3. So this problem right here, this involves exponent rules because just 3 has a power of 1. So if we do the quotient rule with our exponent rules in this part right here, we're going to be left with log base 3 of 3 squared because 3 minus 1 is 2. Now this then can be written as log base 3 of 9, and this is the reason why that we like to condense, because look, I went all this way to write it as a single logarithm, and now I'm going to ask you, okay, can you evaluate this? 3 to the what gives you 9? And your answer is going to be 2. Alright, so take a look at number 5. This is similar to the one that we just did, except there's 2 coefficients in front that are going to fly to be the power of in our log. So we're going to have log base 7 of x to the 3rd minus log base 7 of y to the 5th. So this is our first step. Then you're going to notice that it's the quotient rule. Since the y to the 5th is after the negative, that's what goes on the denominator. So you have log base 7 of x cubed over y to the 5th. Number 6. Okay, in number 6, we are dealing with the product property and the quotient property. Now this is what you need to remember. If there's a positive sign or if it's a positive log, then it goes in the numerator. If it's a negative log or there are minuses in front, then that goes in the denominator. So you're going to have log of x times y divided by z, and that is your final answer. Okay, so take a try at number 7. It's very similar to 6. There is a little twist, a little addition to it, but go ahead and try this one. Okay, so the first thing that you're going to do is you're going to distribute this minus sign right here. And you're going to get log of A plus log of B minus log of C minus log of D. And if you remember what I said, if there's a plus in front, that goes in the numerator. If there's a minus in front of the log, that goes in the denominator. So your final answer is log of A times B over C times D. Go ahead and try number 8. So the first thing I noticed that there's this coefficient, or in this case a variable, in front of our log. So this is going to fly. Alright, so we have log of 5 minus log of 2 to the k. This minus sign right here tells me we're going to do the quotient rule. So my final answer is going to be log of 5 divided by 2 to the k. Alright, so number 9 is actually a challenging problem, and we're going to walk through it. Okay, so in number 9, there are two coefficients, the same coefficient, but this 1/2 is going to fly. Now, this is the key. This 1/2 is in front of the whole log, this whole 4x and this whole 9x. So we need to put parentheses here when we raise this to the 1/2 power. So our first step is log of 4x to the 1/2 plus log of 9x to the 1/2. So now we can take 9x and 4x to the 1/2 power, but we needed to do that separately so that the base is 4x and the other base is 9x. So I'm just going to write out every single step. If you can skip this next step, then that's totally fine with me. Alright, so I'm going to do the power to power rule, and I'm going to have log of 4 to the 1/2 times x to the 1/2 plus log of 9 to the 1/2 times x to the 1/2. Okay, so this 1/2 power with the 4 and the 9 should kind of be a quick rational exponent that you should be able to evaluate. So 4 to the 1/2 is like saying the square root of 4. So I'm going to have log of 2 x to the 1/2. And then the square root of 9 is how you can think about this next one. So I'm going to have 3x to the 1/2. Okay, so now I'm going to write this as a single logarithm, and I'm going to have log, and I'm going to, what property are you going to use here? We're going to use the product property because of the plus sign. So I'm going to multiply 2 times 3, and I'm going to get 6. And then when I multiply x to the 1/2 times x to the 1/2, I need to add those exponents, if you remember that exponent rule. So I actually just get left with log of 6 to the x, because 1/2 and 1/2 is 1, so you just get x. And this is our final answer.